Okay, so there are going to be some situations when what we call divide radicals. So here's the thing. You can't have, draw them up here so you can see. You can't have a fraction under a radical. Okay. So we need something like this, an entire fraction, like let's say 2/3 under a radical. You can't do it like that. That's not completely simplified. You also cannot leave a radical in the denominator of a fraction. Okay, not completely simplified. The only place in a fraction where you can have a radical is in the numerator. Okay, and then it must be completely simplified like we did yesterday with our radicals. So if we have an entire fraction under the radical, what we're going to do is we're going to use the quotient rule to break it apart. And what I mean by that is if you look here on your notes, it has the square root of some fraction a over b. What we're going to do is we're going to just take the square root of a over the square root of b. So we're going to split it up and we're going to take the square root of both the numerator and the denominator. And when we have fractions, we can simplify first to make our numbers sometimes smaller and easier to deal with, okay? What it says is we're going to first of all look for perfect squares in that numerator and in that denominator just like we did yesterday. We'll just treat them separately. Then we're going to simplify by dividing or reducing if they are both under the square root sign or both not under the square root sign. And then we will simplify any resulting radicals, okay? So it's just a lot of simplifying here. So here's where I'm going to start. First of all, I have the square root of an entire fraction, the square root of 49 over 100. So the first thing we're going to do is we're going to split that apart. We're going to take the square root of the top number and we're going to take the square root of the bottom number. Okay. And so what that means is I'm just splitting it up. I'm going to do the square root of 49 over the square root of 100. Now, 49 and 100 are pretty large numbers. So what I can try to do is simplify them. And what I mean by that is do 49 and 100 have anything in common that I could divide out? Like, are they both divisible by 2? Or are they both divisible by 5? Or anything like that? 49 and 100, do they look like they have anything in common? No. The next thing I'm going to look for is, are they both perfect squares? Can I get rid of the radicals by just listing perfect squares or simplifying perfect squares? So start at the top. Is 49 on my list? Yes. What is the square root of 49? 7. Okay. So that's going to turn into just 7. Once you simplify the square root, the radical disappears. And then is 100 on my list, or is 100 a perfect square? Yes. Okay, so what is the square root of 100? 10. Okay, so that's going to turn to just 10. Now, just keep in mind, sometimes they're going to do numbers that aren't on our list, so you're going to want to check with your calculator first. Try to simplify it to see if it's a perfect square. You'll know that if it doesn't give you a decimal, okay? If it's not a perfect square, we'll talk about how to do that in just a few minutes. Can I reduce 7 over 10? Do you guys remember how I taught you how to reduce fractions in your calculator? You can check it just to see. You can enter 7, hit your fraction key, and hit 10. Then hit equals. If it gives you 7 over 10 again, that means it doesn't reduce. Does everybody remember how we did that? Hit 7. And then your fraction key is the ABC key. No, reduce fraction. So what you do is you hit the numerator first, so hit 7. And then hit the denominator, so 10. You see how it just gives you 7 over 10? That means it cannot reduce. That would be better. If it reduces, it will give you a new fraction. Can 7 over 10 reduce? No. All right. Is everybody kind of okay with that one? All right. Let's take a look at number 2. I got the square root of 8 over 32. The very first thing we want to do is split it apart.
That's easy.
It is? Okay. Split it up first. Now, do we notice that both 8 and 32 are both under my radical sign? So what I want to do next is I want to see, can 8 over 32 reduce? So do that in your calculator. Hit 8. Hit your fraction key and hit 32 and hit equals and see if it gives you a reduced fraction. Does it? Yeah. What is it? What is this fraction it gives you? 1/4. So that is going to turn into the square root of 1 over the square root of 4. What I did was I divided both of those numbers by 8. Both of them are under the radical sign, so if they can simplify, I can make my numbers smaller, which usually makes my job easier. Now, let's do what we did before. Is 1 a perfect square? Yes. What is the square root of 1? Okay. Is 4 a perfect square? What is the square root of 4? 2. And so my most simplified answer with no radicals now is going to be 1/2.
So if you leave 1/4, you're wrong.
Yes. Is everybody okay with how this is working so far? 1/4. I divided both the top number and the bottom number by 8. 8 divided by 8 gives me 1. 32 divided by 8 gives me 4. Just to get smaller numbers so I don't have to deal with such large things. Is everybody kind of okay there? The square root of 1. Okay, so the square root of 1 is just 1 because it's my first perfect square. And then I took the square root of 4, which is 2. Is everybody okay with that? Okay. All right, let's take a look at number 3. Same process. I have an entire fraction under a radical sign. So the very first thing I want you to do is split it apart. We're going to take the square root of 3 over the square root of 16. Okay. Then we want to check. Do 3 and 16 have anything in common that I can make them smaller? No. Then I want to check to see if either of them or both of them are perfect squares. Is 3 a perfect square? No. Okay, so what I'm going to do right now is I'm just going to leave that 3 alone, and it's going to stay under the radical because it cannot simplify. Then I'm going to look at the denominator. Is 16 a perfect square? Yes. What is the square root of 16? 4. The only other thing I want to check is that top part, that square root of 3. Do any of my perfect squares other than 1 divide into 3? No. So that means I cannot simplify the square root of 3. Did I get rid of my entire fraction under the radical? Do I have a radical in the denominator? No. So that means this answer is as simple as it gets, and we're going to leave it just like that as the square root of 3 over 4. Okay, the big thing here is you can't leave an entire fraction under a radical symbol, and you cannot have a radical symbol in the denominator of a fraction. Try number 4. It's very similar to 3. I see what some of us are doing. Okay, hold on just a second. We're splitting it up, right? Y'all are doing what I told you to do, but this one's leading us in the wrong direction. How many of you reduced that to 107 first? Yes, it reduces, and we can still simplify, and I'll come back and show you how you would do it in just a few minutes. But what do you notice about that denominator before I even think about simplifying it? That 49, it is the what? It's a perfect square. So essentially on this one, we would want to take the square root of that 49, which is just 7, right? Does the numerator, the square root of 7, simplify? No. So it should be like this. Okay, and I'm going to put a pin in that for just a second. I'm going to show you one more example, then I'll come back and show you how we would get that same answer, Zion, if you had simplified it like you just did, okay? Make sense? Is everybody okay with that one? So I simplified if my numbers are big, but I probably should have specified check to see if they're perfect squares first before you simplify, okay? Does that make a little bit of sense? Yes. It just shut off on me. It does that sometimes. Okay. All right, so we'll come back to number 4 in just a minute after I do a couple of other examples. So then we have to talk about what we call rationalizing the denominator. And it says, to be fully simplified, there is no radical left in the denominator, which is what I showed you. We're not allowed to have something like that. And this can occur sometimes with dividing. So the process of getting rid of that is called rationalizing the denominator. To rationalize a denominator, what we are going to do is we are going to multiply both the numerator and the denominator by the radical that's in the bottom. Okay, then we're going to simplify. You're going to multiply both the top and the bottom of the fraction by whatever radical is in the denominator, and then we will simplify from there. Okay, that's what we're going to have to do in order to get rid of the perfect or the square root in the denominator. Is everybody ready? So we're going to look at 13 and 14, and then I'll go back up to question number 4 to show you that one. Do you notice how in number 13, that top number is not under a radical sign and that the bottom number is? Okay. And then in 14, do you notice how they are both under the radical sign? So we have to be careful because they're going to be treated just a little bit differently. So I'm not allowed to leave that square root of 7 in the bottom of that fraction. And what my directions tell me is that I'm going to multiply both the top and the bottom of that fraction by whatever radical is in the denominator. What radical is in the denominator? The square root of 7. So this is what I'm going to do. Whatever I do to the bottom, I'm going to do to the top. Okay, so we're going to go the square root of 7 and the square root of 7. We're multiplying both the top and the bottom by the square root of 7. Okay, now here's where I need you to pay close attention. When I am multiplying numbers, I have to multiply what's in the same position. What I mean by that is a number that is not under a radical cannot actually multiply with a number that is under the radical. So for example, in number 13, that 4 is not under a square root sign, correct? But the 7 is. So I cannot actually multiply those and get 28. But what I can do is just multiply 4 times the square root of 7, and it stays just like that, 4 times the square root of 7. Okay, that's technically multiplying them, but we can't actually do 4 times 7 and put 28 because the 4 is not under a square root sign, the 7 is. Kind of okay? All right. Now at the bottom, they're both under the square root sign, correct? So we can multiply them. So we're going to say the square root of 7 times the square root of 7 is going to give me the square root of 49. Well, what kind of number did that just turn my denominator into? A perfect square. Okay. So let's do this. What is the square root of 49? 7. Okay. And then at the top, I'm going to bring those over for now. Then I have to talk about, can I simplify? Okay. In my fraction, what two numbers are not under the square root sign? 4 and 7. Do 4 and 7 have anything in common that I can divide? No. So those two cannot simplify. What number is under the radical sign? 7. So what I want to try to do is see, do I have any perfect squares that divide evenly into 7? No, which means that square root of 7 cannot simplify. Do you think that I could simplify the two 7s? No, because one of them is under the square root sign, the one at the top. The one at the bottom is not under the square root sign. So since they're not in the same place, they cannot simplify, and we're going to leave our answer just like that. That is called rationalizing the denominator. Okay, so 4 over the square root of 7 in its most simplified form is 4 square roots of 7 over 7. Okay, kind of okay. This should not be the first time you've seen this. You should have seen it in algebra. We're going to do the same thing for number 14. Just kidding. Ready? What am I going to multiply the top and the bottom by here? The square root of what? Bottom one. 2. Okay. The goal is we cannot have a radical in the bottom of a fraction. So therefore, we're going to have to multiply the top and the bottom by the square root of whatever is in the denominator of the fraction. Now this one is going to be slightly different than number 13. When I multiply at the top, can I actually multiply the square root of 5 times the square root of 2? Mm-hmm. Yes, because they're both under the radical, and that's going to give me the square root of what is 5 times 2? Yeah. Okay. Do you see how they're different? I couldn't actually multiply 4 and 7 because the 4 did not have the radical symbol and the 7 did. And then in 14, I can because they both have a radical symbol. What about the denominator? The square root of 2 times the square root of 2 is the square root of 4. Let's go ahead and simplify that bottom part. What is the square root of 4? 2. Maybe. Okay. I'm going to bring over that square root of 10. And I want you to try this first. Does 10 have a perfect square that divides into it evenly? No. Okay, so I can't break that apart. Here's the next question. Can I simplify the 10 and the 2? No. Okay, the 10 is under the square root. The 2 is not. Therefore, I cannot simplify, and we leave our answer as the square root of 10 over 2. Are we kind of getting the idea here? Somewhat, sort of. Okay. Ready? Okay. What's a little bit different about 15 versus, say, 14? They're both under the radical. So when we have an entire fraction, what was the first thing we said we do? We split them up, just like we did at the top. So what I want you to do first is the square root of 81 over the square root of 2. There's a couple of different ways we can do this one. It depends on what you recognize at this point. Anybody want to give me an idea of what they think? Okay, multiply the top and the bottom by the denominator. Is that what you were going to say? Okay, so there's 2 different ways, and I'm going to show you both. It depends on how familiar you are with your perfect squares and what you see before we begin. So I'm going to do it the first way that Zion said, where we're going to just multiply the top and the bottom by the square root of 2. Okay, I'm going to show you how we get the same answer either way. I'm not telling you one way is better than the other. It depends on what you see when you look at the problem. Okay, quick question. Can I actually multiply the 81 and the 2 at the top? Yes. So that's going to give me the square root of 162. And at the bottom, the square root of 2 times the square root of 2 is the square root of 4. Okay, I'm bringing down that 162. What is the square root of 4? 2. Okay. But remember how with number 14 we checked to see if 10 had one of these numbers that goes into it? We're going to do the same thing with 162. Okay. So the closest thing to 162 without going over is 144. With your calculators, does 144 divide into 162 evenly? No. Okay. Does 121 divide in evenly? Nope. What about 100? Nope. What about 81? Does 81 divide into 162? It does. So now we're going to have to kind of put together what we did yesterday with what we're doing today, and we're going to split that 162 into the square root of 81 times the square root of 2. And I'm just bringing over that denominator. It doesn't change. I've already simplified it. What is the square root of 81? 9. Okay. That square root of 2 cannot simplify, and that's going to stay over 2. The square root of 4 turned to the 2 that's now on the bottom. Okay. Which two numbers are not under the radical symbol? 9 and 2. Do they have anything in common that I could simplify? No. Can I simplify the square root of 2 with just 2? Can I simplify this square root of 2 with this 2? No. One is under the radical, one is not. Therefore, my answer is going to look like this. That's one option. The other option, which you may see from the beginning when we split it up, some people recognize before they start getting rid of this square root of 2 that 81 is a perfect square, isn't it? So what we could do is we could simplify it first. What is the square root of 81? 9. Okay. And then we would follow the same process to get rid of that square root of 2. We would multiply the top and the bottom by the square root of 2. Can I actually multiply those two numbers to get 18? No, I just put them next to each other. Can I actually multiply those numbers? Yeah. Keeping the top part the same. What is the square root of 4? And isn't that the same thing we got? Just a different method? So it really depends on when you break it up. If you recognize that this is a perfect square, by all means, you can simplify it first. If not, you can do it the same way we just did up here, and it will work. Everybody ready? Okay. What should you do first on 16? Split them apart. Yep. Go ahead and split them apart. And you may just want to get in the habit of asking yourself, are either of my numbers perfect squares? Are 6 or 18 perfect squares? No. Okay. Now, 6 and 18 are a little bit larger numbers. So before I start multiplying by 18, could those reduce? Do 6 and 18 have something in common that I can just get some smaller numbers with? Yeah. What could I divide them both by? Okay. So let's do that. Let's split it up first. And then because they are both divisible by 3, that's going to turn into the square root of 2 over the square root of 6. And that just gives me some smaller numbers to deal with. Okay, keep working on it. You don't have to simplify. You could use the 6 and the 18 and multiply. You're just going to have some larger numbers with. There's also a different way we could do it too. Some of these can be done so many different ways. Does that make sense? Yep.
Okay. So far so good. What you need to do now, you can't divide because see how the 12 has a radical, but what you do need to check is do any of your squares divided into 12. So could I break 12 down just a little bit? Yes. Okay.
What do we multiply the top and the bottom by? Square root of 6, okay. So that's going to give me the square root of 12 over the square root of 36. Does everybody agree with that? Okay. Leaving that 12 alone for now. What is the square root of 36? 6. Before I keep going, can I reduce that 12 and that 6? No. The 12 has a radical symbol. The 6 no longer has a radical, so they're not in the same place, so I cannot reduce. However, I still need to check the 12. Do any of my perfect squares divide into 12 that I could break it down a little further? What perfect square goes into 12? Okay, so we're going to split that up into the square root of 4 times the square root of 3. That 6 is going to stay. What is the square root of 4? 2. That square root of 3 stays, and that 6 stays. Which numbers can I reduce? They either both have to be under the radical symbol or both not under the radical symbol. 2 and 6 have something in common, but so do 3 and 6. Which pair can I reduce? Which ones are in the same place? The 2 and the 6, okay? This is not under the radical, and that is not under the radical. So I can simplify them and divide them both by what number? Or put 2 over 6 in your calculator and reduce that. Yeah, they're both divisible by 2, right? What's 2 divided by 2? 1. Okay, that square root of 3 is going to stay. And what is 6 divided by 2? 3. Can I reduce those 3's? No. So you can leave it like that. Or if you prefer, you don't have to put the 1 in front. You could just put the square root of 3 over 3. Okay, you just have to pay close attention to your numbers. Are they both under a radical symbol? Or are they both not under a radical symbol? And go from there, okay? Everybody get the idea? All right.